So how are things? Is it good? All
Work is very busy. We at the moment we're given 1 week sprints, and within that 1 week we're making several deployments. So and the tickets often bounce back, so it's crazy. Yeah.
oh, oh. Just a second. So Karthik, it is very clear. Your video is very, very clear, crystal
And
clear.
that's because I'm using Mac today for video.
Oh, is it? Okay, great.
I'm really not comfortable using Mac, but let's see how it will go.
Yeah.
Let's see. We'll see. So, okay, we'll start. So, good morning, good afternoon, good evening, guys, and welcome to this, the fourth section, right? The course is mainly divided into 4 sections, and along with a lot of other practicals as well. Today, we are doing the final section, that is Introduction to Cloud Computing, and welcome to that. And I hope this will be more interactive session compared to other previous sessions, and the more questions you ask, it is going to be a bit more interactive, right? So that is how it goes. It's better to do it that way. Okay, so let's start. We'll talk about a lot of people we are using cloud security nowadays, right? Cloud computing, it has been used, and security in cloud is paramount importance. A lot more. I think recently, I think Wiz.dot got bought by Google for billions of dollars because they were into cloud computing, security monitoring system and things like that, right? So it's a lot of impact is there. A lot of people are moving to cloud. A lot of people are moving away from cloud, and it is becoming a bit more complex, right? And it's no longer, especially in my organization, we are moving away from cloud, but we are putting all the critical infrastructure on the cloud, continue to put out that. Main reason is, I'll come to this point at the later stage when we're talking about that. But before we could talk about cloud security, right? Before we could talk about cloud security, one thing we need to understand is cloud computing, right? So what is cloud computing? In the simplest term, when we talk about cloud computing, we say is that it is someone else's computer, right? As simple as that. For instance, let's say I'm having a very powerful desktop, and you want to run some program in your system, right? But your laptop is not good enough, and you don't want to run this program for a long time. Probably more want to run this program for a couple of hours, and then so only for this using a high-end computer for a couple of hours, you don't want to buy a new laptop or new system altogether. So what you will do is that you will learn, probably you'll rent it out. And in your case, right now, what you'll do is that you'll ask Karthik, can I connect to your lab system and I can run my program for a couple of hours? But when I do that, right? So I'm going to pay you for that part. And that is exactly what happens in a cloud computer. Right? In whatever the virtualization, it is nothing that you're just connecting to a remote computer and you're running services out there in the simplest form, right? But it is then why everyone is not giving a cloud computing service, only why major companies are there and why it is expensive, right? At scale, it is going to be cheaper. If you're doing all together in your system, it is going to be it's going to be expensive for you to do it out there, right? Uh, when you're doing with the very large organizations, this is very much easier out there because they are not just allowing you to connect to a remote computer. That is what we usually we like to think about. So what happens here is that you're dealing with a lot of other things. You're dealing with IP address, network segmentation, WAF, wire network firewalls, and a lot of other things, services are given out there along with the resource sector, right? And this works out a lot cheaper for you, and especially I'm seeing in my computer, right? So before going in further, let me explain what I'm seeing in nowadays and what the clients we are providing or helping them out. What is happening is the cloud cost of cloud is not as same as it was before. It is no longer cheap. At the same time, you need to be very good at your optimizing your application, right? You cannot randomly write the application. You have to be very precise about how you're doing the resource management when you're doing in the cloud. Otherwise, you'll be seeing a lot of, the billing is going to go out of there. And again, selecting the options, you need to have a very good architect out there who is going to select the options for that. So recently we brought on one of the clients cost annual computing AWS bill by about 70%. It was not that we did anything big out there. What we did was we saw what was their requirement, business requirement, and the previous consulting company which were helping them with setting up the cloud. They selected all sort of options, which was royalty options and things which were not required for this service, right? So they had an infrastructure which was capable of managing millions of requests every hour, but whereas they had only about 40 or 50 clients, probably around few hundred requests per hour, right? So the rest of the services were wasted and they were paying extra. And we told, okay, probably we have to bring this down, right? At the same time, you see a lot of people are coming down to on-prem. The development, when you talk about different phases, right? When we talk about development, testing, and production, what they're doing nowadays, we are seeing our clients doing is that they're putting it on their development and testing environment on premises, which we call it as on-prem, and the production is all going to be on the cloud. Instead of running 3 servers in the cloud, we're running 2 servers in the cloud. Only 1 server, it is bringing down, right? And one more thing is you can have an inefficient application on-prem. You can optimize it, then push it to cloud. The main reason is that you have already paid for this resource when you're using an on-prem entity. Whether you use 10% or 100% of the CPU utilization, the cost is not going to work because you've already paid, and that's how it goes. But that is the thing, right? So cloud computing plays a very important role. Cloud computing plays, and we are seeing, it is very more important now. The main reason is a lot of organizations putting the critical infrastructure, their production server, their production data that is more important is no longer on-prem, it is always on cloud, right? It is much more easier to get a compliance, ISO 27 compliance done if your data is on the cloud, because there's a lot of production AWS gives, which I don't have to worry about, right? All those things comes into play. But what are the things that we need to look up, right? Because there are a lot of things that I need to consider. As I told, in cloud computing, the data is not, or the computing is not in your system, right? It is in some other location. You may be selecting Los Angeles location or a US location in somewhere in Texas, or it could be Denmark. Different locations are there, and you are going to select them, and the charges are going to go for based on that. So here, none of your servers are on your location. So who is responsible for security? Right, there are multiple things, right? So see, when you talk about security, it is also about physical security. Someone should not come into the organization and pull the hard drive or take the server and get away with it, right? Think about your laptop. Your manager who's having a lot of company data on the laptop is sipping a cup of coffee in a cafe, and someone steals his laptop, right? The reason why your mandatory requirement to encrypt your hard drive is just for that part, right? So that you don't, we have to be very careful with that part. So even if it gets stolen, data is not. Similarly, who is going to take care of the server, right? Who is going to give this important out there? Then again, you are going to look into operating system updation, right? Security updates you get, you're using Windows or Mac, you're using UC, right? The updates are coming and you have to install those updates. So who is responsible for this, right? Then again, let's say you're using application you have created, and there's an application level access control, right? So for instance, let's say your infrastructure is your physical server. Your platform can be talk about is operating system that you're using, your Windows, Mac, or Linux. And application, let's say you're talking about HR portal, right? Where the HR logs in, where she will enter all the employees' details and she'll track the salary, number of days they're working and things that is there. Whereas the employee can see their own data, their information, when they have applied for job, leave, and when they are, working, what are the days, salary they've got the previous month, but they cannot get the other person's salary information. They can only get their information, right? There's an access management for that. So who is doing access management for this? So all those things we need to consider in a cloud computing as well. What is the things that we are going to look at, right? So that let's look into that part. So first and foremost is who is responsible for what, right? Who is responsible for what? User or the cloud provider, right? I have an AWS server. Who is responsible for its security? Either it's going to be me, the EC2 respond the user, or the AWS is responsible for that, right? So for this, before we could tell who is responsible for, we have to understand the three different cloud models that are there, right? That is, infrastructure as a service, platform as a service, and software as a service, right? The more infrastructure as a service responsibility is going to be the customer's end, right? And the more software it is, responsibility is going to be provider's end. Okay, I'll give an example for this as well. So infrastructure, a lot of people think is when you take an EC2 instance, that is the infrastructure as a service. In fact, that is not an infrastructure as a service, that is a platform as a service only, right? That is nothing but a platform as a service. But what is infrastructure? When you look into a large server farm, there'll be probably thousands and thousands of servers out there. And sometimes what they will do is that, let's say a bank is there, is going to go reaches out to AWS and they'll tell, hey, I need about 100 servers dedicated for me. And you cannot have any other customer information because one server is there and there are a lot of virtual machines running and one of your virtual machine is that. So technically you're sharing that information, right? You're sharing that rack with some other, users as well. But here you're going to tell you that complete infrastructure is mine, this particular service I want, and I want to have complete access to that, right? So something like a Proxmox or, OpenStack that you're going to be given access to, where you can set up, you can decide, they are going to give you about, let's say about 100 processor, 200 GB or 700 GB of RAM and other things. You will do the provisioning. You will decide what my instance it is going to be there and everything. They're going to be charge you flat for that. And that is what it is. And predominantly we don't see infrastructure as a service. But there you are responsible for everything out there, right? Especially when you go to private cloud, it is even more, right? Because in private cloud, you are given a complete new infrastructure separated. You don't share with others. You're not sharing your infrastructure at all with anyone, right? Whereas infrastructure as a service in public, you in thousands of servers, certain section is given to you. I think in private, it is going to be separately, completely everything is going to be given. In a platform as a service, what is going to happen is that you're going to be given a platform, either a Windows platform or a Linux platform. It's predominantly your EC2 services or S3 or anything for that. That is what is going to be given. So see here, are you someone who is going to decide what is the hardware is going to be? No. Are you going to decide what processor is going to be, what hard drive, what SSD drive is going to be? You don't have control over it. That control is taken care by the AWS, right? Here, only thing is that I can decide the number of cores I want in a processor, and I decide what is my hard drive size, and I'll decide what is my RAM size. Then I'll be given an access to that, right? On top of that, I'm going to install an Ubuntu operating system. So here now, you have to think, what is the cloud provider's responsibility? Only from an operating system updates are responsible by the cloud provider. Whereas the user management in those Linux servers, right? So let's say I'm creating 3 to 4 administrator, 1 developer, will have access to particular, all those things have to be taken care by the client out here, right? The operating system security patches is taken care by whom? It is taken care by the provider, that is the AWS or GCP or anyone like that. But the operating system level services, what service, what firewall, what is, all those things has to be taken care by the client out here, right? And finally, here will be the software as a service. Software as a service, basically, you don't have access to anything, right? You don't, for instance, let's say a simple example, what we can tell is that the Gmail services, right? Any organization nowadays, it is very rare nowadays you see organization running their mail servers, right? Their own dedicated mail servers. Only the large organizations we see. Shorter organization, they don't do it at all. Either they go with Gmail mail service or an Outlook or something else out there, right? That is how they do. So in those situations, you don't know where is your server is, whereas in EC2 platform, you know which location your server is, right? Which city, which server farm that your server is located. But in software as a service, your Gmail is a software as a service. It's a cloud service that is being given to you, right? Your Dropbox is a cloud service given to you, right? Your Google Docs is a cloud service given to you. Anything that you're using over the mail in a browser is a software as a service. So here you don't have control over the hard drive. You don't have control over the operating system. You don't have control over the what software that is being used for developing that particular application. You don't know whether it is developed using Java, Python, what kind of a database they're running. You don't have any control over here. So, but everything is decided by whom? The cloud provider is going to be responsible for this. Because since he is having control over it, he is the one who is going to be security responsible for all those things. So what are you going to be responsible here? So here it is very simple. It becomes a bit more easier, right? Number of tasks I have to do for securing is also reduced now. So what I have to do? Only thing I'm going to responsible here is I'm going to create users who can have access to Gmail, and I'm going to give them permissions on my Gmail dashboard, which user is having what services. Right? Are they having it? I can decide what is the Google Drive, limit for that, and all those things can be done. But again, this is a very different kind of a service security responsibility, right? Predominantly what you call IAM policy, identity access management. We'll see what is their identity and then take it, right? Here, think about one more thing, right? When you're using Gmail or any cloud service provider, you don't even have control over the authentication method, right? How the authentication, where is your username, where is your password stored, how it is stored, what kind of a security has been given, all those things you don't have to. But it's a good thing because the big players know how to provide security at a very scale and very efficient way, rather than developing all those applications yourself, right? Very large organization doing billions and dollars of sales who don't have that much footprint, right? The meaning they don't have thousands and thousands of users, they still go with Gmail. It is very good service. It is, but that is a software as a service. You don't have a server on-prem, you don't have access to the server on the cloud, but you're only going to use the service, right? So that is why it's called GSU, right? You get documentation, you get storage, you can get, there's a lot of things that you can do with it, right? So these are the three different models that you'll see, and we are seeing who is responsible for what. We'll have a much more detailed understanding here, right? Data classification. Probably we can go from bottom to top. If it is on-prem, it is entirely your responsibility. And a lot of organizations, they don't go with on-prem. I'll trust me. We are using, when we see our clients using on-prem, they're using completely free tools. There's nothing much apart from the physical server expenditure what they're paying. It is still not cheap, right? The main reason is that when you're managing things on-prem, there's a lot of activities that we have to do, and because A one person who can be taking care in the cloud, they probably need a 3-member team on-prem, right? The salaries are going to be much more higher on them. It only makes sense to go on-prem if there's the cost of running on AWS is much higher than the salaries, right? And again, the usability also makes a huge difference because everything you have to take care, you have to be very sharp physically, you have to give security, you have to make sure you're constantly updating your hardware, BIOS and everything, whatever the hardware level security patches has to be applied, operating system level security patches has to be applied. Your platform patches, like whether you're running a Java application, Spring, Python, Django, and things, you need to take care of everything out, right down to the, then again, you have to do the application security testing as well at the end of the day. Unfortunately, it can be quite overwhelming if you're doing everything on your own, right? So security plays one of the reasons why people have, if cybersecurity was not an issue, people would have, not moved to the cloud, or they would have migrated from cloud to on-prem much more faster. Right? It is become much more easy to manage it on cloud, right? So as I told, infrastructure as a service, the cloud customers are going to be more responsible for that. In network infrastructure and physical security is where you will see cloud providers having much more access, right? Application control, everything has to be taken care by the uh, cloud customer itself when you go to PaaS. And PaaS is where we generally see 90% of the cases people are using uh, cloud. You're going to see PaaS is going to be that. Data classification, who is having access to what data, S3 is having access, which developer is having access to which instance, all those things we take care in PaaS manually ourselves. Client is responsible for that. Endpoints are also responsible, meaning your browser and from where you're connecting, that is also your responsibility. Identity access management is going to be a bit more difficult. Right, it is going to be divided between the cloud provider and the customer, and the same level application level controls as well. That is going to be there. So, but when you go to SaaS, software as a service, data classification, accountability, and client and endpoint protection. Right, endpoint protection also here means the tools that you're connecting to connect to the AWS or your cloud provider. Right, that also comes into play. So they can control that part. The provider can control that part, making sure that is in a good security place. That is there, and browser they can give security for. They'll tell, okay, if the browser is not of this particular security patch is not applied, I'm not going to allow you to access for that. And that we are seeing happening more and more nowadays as we are moving towards zero trust architecture, right? That is the identity access management is more towards 50-50 out here, right? For admin roles and other things, that's going to be, they'll take care of it. Multi-factor authentication, forcing a multi-factor authentication. I cannot tell that certain things we will not allow multi-factor authentication. It is going to be forced into that part, right? So that is how it is going to be the component on that, right? Any questions, guys, till now? Any questions till now?
No.
Okay, thank you. So what is how do you provide security? What are the things, there's, as you go further down, are you working more on cloud, there are a lot more things that you will do, right? At a very granular level that you're going to be there. But as a whole, what are the bare minimum things that is required? We'll look into this, right? So what are security groups, right? So that is what one thing, one level of security in a cloud environment is security group, right? A security group acts as a virtual firewall for EC2 instance to control incoming and outgoing traffic. Both inbound and outbound rules control the flow of traffic and traffic from your instance, respectively. Right. So usually in AWS security group helps you secure cloud environment by controlling how traffic will be allowed in your EC2 machine. Basically, here we're talking about whitelisting, right? And telling who is allowed to access, who is not allowed to access. In certain cases, I can tell this particular AWS instance has to be allowed to access only from a particular network itself, right? We have seen our clients will tell a particular server, when you're connecting, the web server is accessible from anywhere in the world, right? Port number 443, anyone in the world can access it. But when it comes to configuration, that is connecting via SSH to those systems, then you can have a limitation saying that it has to come from a particular IP address or it has to come from a particular network itself, right? One of our clients made sure we cannot access the server beyond their network, right? When we went for penetration testing, checking their configuration review, they told you cannot do it from your office. You have to come down to our office and we'll give you the access for that, right? So usually in some cases, they will give us the laptop and other thing. In this case, they told, we don't need a new laptop. You can get your laptops. We will check it once whether everything is fine. After that, you can connect to it directly, right? So you have to be in their office network to access for that part, right? And ports and which are things and what kind of, all those basic things will be taken into consideration right here. And the security groups will work to help you with that part. See, this is something which is a first line of defense. You can see when you're talking about this, it is talking something similar to a network firewall. And that is how it works, right? It will help do that part. As we say, cybersecurity is more about doing layers, more than one level of time. So what is the next layer in security for cloud security, right? So this next one is the management plane. Management plane is single most significant security difference between traditional infrastructure and cloud computing. This isn't all of the metastructure, but is the interface to connect with the metastructure and configure much of the cloud. Thus, gaining access to a management plane is gaining access to your data center. Cloud provider into private cloud provide high level of availability and mechanism for customers to manage aspect their own availability. Ensure there is a. So what do you mean by management plane? Basically, whenever you log into your AWS account, you get a management console or a dashboard where you can provision and we can remove or delete, instances and things like that. Securing that is very much important out there, right? You can set up a lot of things. You can do geotagging. Your management plane cannot be accessed from any other country. It can be geotagged to your location. All those things can be done. You can even tie it up to a particular system or a network as, all right? And again, password management and access management to this kind of an infrastructure dashboards are very, very critical. Right. I'll tell you, give an example. Recently, one of the biggest startups in recent times, they got hacked and they lost all their data. Not only data, they lost their code, source code and everything. Everything was deleted. What happened was one of the employees was fired. He was so disgruntled. He had an admin level access to a lot of infrastructure and things. He went there and deleted one by one each and everything out there. Luckily they were able to get it back, but they lost a lot of business, a lot of credibility, right? It does not make a difference, right? They should have done a lot of due diligence, before letting someone go. They have their access rights has to be removed, which was not done according to the compliance perspective. They would have lost their compliance as well because of that. Securing this is very important, right? And we see, sometimes when we go and check it out, the password policy that they're setting up there, what is the password is being used and everything, it will be very easy to do. Sometimes admin is what is going to be there, very basic passwords and things. You have to take care of that, right? So use strong for authentication, use multi-factor authentication, separate, different administrators for different jobs and everything. Don't give super administrator rights to everyone, right? You can have a particular access given to a particular set of resource to one administrator. There can be one administrator who's having complete access to all the infrastructure, but we have to be very careful with that part. Just a second. Just a second. Right. So it's important. It is important that we give access rights and properly manage access rights to management plane as well. So infrastructure security, this place, do a lot of don't give access for that. Management plane is one place. That's one thing. But a lot of times, what happens is that a typical organization, right? What I have seen is that let's say they're running about 3 to 4 applications they're running, and typically they'll be running about 50 servers, right? For different things, for different activities. They're running, testing. There are 2 testing environments, one development and one production, and things, and a lot of other things like, their pipeline is running on a different server and running other services, SonarQube and artifacts and things management and things they could be running on, right? So it will go anywhere between 30 to 50, depending on what are the things they want and how much segregation they want. And the more segregation, more fine tuning, it will take more. But how is that? How is that you're giving access for that, right? I'm talking about here from storage perspective also. And S3 is also taken as a separate server out here for me, because for me it's a separate instance, right? How is that you're doing that part? So how is the security given for that? Are you giving any kind of security for that? What is the password management policy for that part? Recently, when we are doing an audit for one of the clients, they have an MySQL server setup out there, and it is open, right? And they we were able to connect to the server using a default username and password, right? We gave admin and logged in, and we were able to dump all the database, right? And their giving response was very, they told it's a development server, it's not a production. We have that. They had a similar pattern in production as well, right? They had a user which is a predictable user, and we ran a tool for checking out, but it was still possible to break into that. They did not. There is no password policy maintained out there, and it was kept very simple. And their reasoning is sometimes it's very common. Why do you think hacker will focus us? Why do they want to compromise? And there's no reason for that, right? It is very difficult, and also you'll see that they don't get patched quite often. The logs are not generated. They're not constantly checking the logs, who is accessing what and what time. And why is that? When we go into these services, we're looking at configuration. When we see at the history command, what commands, sudo commands were running out there, it is absolutely, we don't know who is running what commands on them. There's only one user and 10 developers are connecting to the same user and running all the commands. We have no idea which user is running what commands on them, right? So those are the things that you need to be very, very important out there from an infrastructure point of view. Making sure, right, anyone is able to access. They're running SSH in a default port. You don't want to be doing that part, and you don't want to give access to SSH from anyone. You don't want to give username and password based authentication for SSH. Making sure you have a passwordless approach. Those are the things it's not been done out, right? So how do you look into that? So that is very important. So when you're talking about infrastructure, make sure don't give a company level access. If there's an entire team working on it, they're about, let's say, the 10-member team in developer team, they're working on a project. All of them don't need access to your server, right? They should be able to test on their local server and push that code, raise a PR. Let's maybe 2 or 3 people will need to push that code to the server and try to build a application and run from that, right? And probably it may not be a good idea to build on the same server as you're running the production server, right? Probably build and then move the code back, the build files to the production server. That's up to you to take it, right? And how you're accessing that. All those things you have to take care of it, properly manage it. That's very much important. Insecure interfaces and API, lock. One of the places where we see, right? One of the places where we have seen people have lost money and they have not given production, is Google Maps API. Right? When you open a particular website, you'll have Google Maps out there, and in those things you have to pay for that. Google is going to charge you for that, and they'll give you, and they will not properly secure it, properly authenticate it. So meaning I can copy that code and put it in my website, and people using Google Maps in my website, they'll be charged to the other guy. That is one thing. When there's a communication between two APIs, there is no encryption. There's no communication is not encrypted at all. And that is also one issue. Just like in any web application, session management between two API, when you're interacting in video, it's very much important, right? It does not mean that because there is no browser involved, I cannot do hack or anything. I can still be able to do into that part, and there's no input validation, right? We see a lot of places, right? A lot of times, whenever we talk about vulnerability and anything, the development team will come is that was an issue with the front end. We have been telling them this issue has to be fixed at the front end, at the React level, at the JS level, or anything. We tell them no, this is nowhere. Security is usually not an issue with the front end, right? Because the validation has to happen. Validation has to happen at the server end itself. A lot of times, what's going to happen is we can do password bypass, right? Password bypass, that is a password policy bypass. Usually there'll be in front end, there'll be sufficient technique out there telling that you cannot, you have to be 8-character long, is capital and everything. But I can intercept that request in Bob, so somewhere in the middle, and I can make the changes and make them have a low quality password. It is always the server side that's going to be there. The validation, the input, whatever the input is you're getting out there, that validation is very much important, right? Logging and monitoring is also important, right? A lot of times, if they properly monitor what is happening, why system was out and everything, they have a logs and everything. Even if they're attacked, they will know where, how they were attacked and things like that. If you don't do that, that is going to be very, very difficult, right? Recently, one of the clients server went down. It is not because of an hack or anything. There was an application fault. They did not know why it went down. They don't know how to fix that thing. The reason is the developer forgot to set up log files for that application, for that particular feature. So now they had to redo it again, reapply the logs, set up the logs, and wait for that error to become again, right? Because they have no idea what happened. But anyway, for them, that error came in again, and they were able to understand what's happening. But what if there was something else from a security perspective? This is going to be a major issue, right? It also you have to look from an API is whether these APIs are updated and unpatched softwares are being used out here. It can have a lot of impact on that. Always make sure, one of the main advantages of using CI/CD pipeline is that it will constantly check whether the software that you're using, if you're having a proper, SCA composition, software composition analysis done properly, it will make sure that it is not any outdated software is not there. But you have to do it manually as well, right? You have to take care whatever you have to sit down. Architects have to sit down, security team has to sit down with development, scrutinize what is happening out there, look into that, what are the components that are used. Especially the DevSecOps team can have a huge impact on it, right? And right, the assumed protection, their parity during cloud conversion, and other things, overly permissive access control, lack of rate limiting. So rate limiting permission access control, meaning it is giving a lot of permissions to a lot of people, right? When you're talking about, as I told, I personally in my organization, I don't allow developers to run any kind of a code or anything on the production server. Only the bare minimum code has to run, and if they're building out anything, which is if it is required to be run on production, it will be run. If it is not required, it will be done on another deploy, build server. It will be built out there, push the artifact into some artifact location, and from there pull it from the component to the thing out. right? So usually what we do is that Docker containers are going to be pulled from a separate location on them. So that is what, and make sure why is that all the developers need to have access to the build cycle, right? Only one of them can more than sufficient enough, and probably two maximum if there's a requirement of that, right? If more than that is required, you need to have a legitimate permission from the manager or a director or a VP for that project, telling them they're taking responsibility, why they're giving so much access for that. The main reason in some situations it may be necessary, right? They have something critical. And you have to make sure not that they get the access, why they get and for how long they want. And if they're telling, okay, we need for this 15, 20 days, after that it's not required, then making a list that you need for 20 days, after 20 days, removing it, right? Zero trust, don't trust anyone, right? After 20 days, don't trust that person is going to be a good person and continue be. You can take the data anytime you want, right? Right, that is there. And lack of rate limiting, right? Rate limiting is nothing but a DOS attack, There's an API server listening for some kind of a request coming in and trying to process it. If I can send in a large amount of that, it's going to crash the server. Right? Some of the clients servers can be so difficult, even running a normal scan there, we have faced issues with it. Right? We have not been able to get any information from there. So that is, we have to take into that consideration. Your application should be able to take a lot of load. At the same time, we should have a mechanism that if there's a one client sending about 1,000 requests in a minute or 100 requests in a minute, then probably you should drop that particular client. Right? You should not process requests from that because he may have been trying to bypass your authentication. He's trying to brute force attack on it. It could be anything, right? Usually we'll keep it to 50 requests in a minute's time. Usually it does not go beyond that. In some situations, we'll do it more than that. Main reason is in certain applications that is there, but there we have to look into that and ask the development team what is that the ideal number of that, and probably have a 10% increase in that number, right? That is very much important. So when you're running into APIs from your cloud, make sure all those security features are there. We have seen S3 buckets completely open. There's no authentication done at all. All those things are done. Insecure third-party resources, right? Cloud computing adoption is rapidly, and third-party resources could mean different things for external written code through open source library to SaaS product. Because product or a service is sum of all other products, so exploits can start because of any component, single line of code integrated within the application. For the malicious hacker, this means that to achieve their goals, the only need to look is for the weakest link at entry part. So probably I think we have seen a lot of external, right? If you see Python gets constantly, Python is one of the most third-party resources used on cloud, especially when it comes to data analytics, big data, and a lot of other things that is used, right? What if there's a security vulnerability in that? Your code is absolutely right. Your interfaces you have kept coming. Your AWS is completely secure, right? But the code vulnerability that brings up here is because of your third-party code, right? And recently you might have heard about Node.js vulnerability as well, right? I think Node.js vulnerability is more towards from a client-side perspective. I've not had an opportunity to go through that, but that is considered one of the biggest supply chain attacks we have seen. It is used for mining crypto and other things, which can have a huge impact as well, right? So you have to be careful with that. Insecure software development process. And this is the most difficult part for me in my job. Especially I'm more involved in product development these days, is to get the developers to do the work properly in a secure way, right? So they can do a lot of, we know what is the issues that are there. We need to talk to the developers well in advance. This is what is required, the security is there, and they are also, and it's not that they are, they want to bring the code down or they are not interested or anything. they do have deadlines and they want to finish the code, and amount of load they're getting is quite high, and trying to look into the security is going to be very difficult, right? So it becomes a bit more difficult, but CI/CD makes it a bit more easier, right? We can get the vulnerabilities on the Sonar Cube, Sonar Cloud, look at it, look at the images are secure in a way and things like that. This is very much important, right? The development process, security has to be implemented well in our part, right? Nowadays we are seeing, I think, with AI coming in, right? It has been a bit more easier on the developers. There are, you can also, as a better way of doing a code reviews and things like that from them, right? We are able to have a much more better approach to that part. In some cases, it can even recommend some kind of a coding practices out there. So that's that. But insecure software development depends on the team. There's a constant training that needs to go from the security department, telling them this is what is required, right? And usually their approach, they think this has to be fixed at the development play, at the operations, level, but not always. If something can be fixed at operation level, we are going to provide security for that. But on top of that, since this is a layered approach, even they have to provide security of that, right? You have to have a very thick skin out here, right? People who are working on DevSecOps will have an idea. It becomes very difficult, right? And this is where, as an ISO self-management policies are important. In one place, in one of the clients, when we tested, we told you cannot launch the application. This is not is supposed to do, and the development team did not care. They told no, this cannot, we cannot do. This is very crucial. We'll fix it in another 5, 7, 10 days time, right? Which they did, but we told there was a management rule telling that if there is a vulnerability of critical or high nature, the application cannot be given a go ahead for that. They have to fix it. Only then they can be launched, right? So that is the reason they could not run that, push that code to production, and they had to fix it, right? Otherwise, they would have gone for another 10 days, 20 days. Probably they'll tell we'll do it in another couple of days. They'll keep on pushing, right? But if that gets stuck out there, they will not do, right? So guardrail is one of the tools you'll get for secure development features in AWS. You can look into that. CI/CD pipelines is going to be there, right? So encrypt data in motion and at rest. So what does it mean? Encrypt data in motion and at rest. What does it mean? It is important that the data is encrypted whenever you're storing it, right? For instance, if you're using an office laptop, you'll see by default it's going to be encrypted. Hard drive is going to be encrypted. So that is data at rest, right? Even the servers need to be encrypted on them. If someone steals your hard drive, and this happened, right? This happened. I'm not recently the technician who came in, right? There was an issue with one of the rack servers. He came in, he took that data hard drive from a wrong server and went away, right? And all servers are down, and we are not understanding what's happening out there. Then we got there, then got to know that that guy took the wrong server out there, right? Hard drive from a wrong server. So we had to call him. Then he came back and inserted took the right. But still, right? What if in that someone did it on purpose, right? So even he took the data, it was not going to be an issue for him because it was encrypted out there, right? That is important. Encrypted in motion is basically when you're moving the data. So usually what happens where the data is moving, either data is moving from the browser to the server, or from the system to the server, or from server to another server, right? So we have to make sure whichever the port we're using, we have to make sure the data is always encrypted. So someone is capturing the data, they should not be able to do that part, right? Especially in mobile, we see this is happening very well now there, right? Since SSL pinning is much more stringent in mobile, it makes it a bit more easier to control this, encrypt data in rest and in motion, and again making sure it reaches the right set of people out there. That's important, right? communication has to be encrypted by default, no questions asked, right? Nowadays in compliance, it is not only the encryption that is important, the what algorithm you're going to use, that is also plays a very important role. Okay, that is very crucial for it. So any questions till now, guys? So accidental cloud disclosure, right? This is something which we see a lot. So meaning what happens is that they don't know that data is public, right? So a simple example was they are using authentication to connect to a GitHub repository for their one of the projects, and everything is going on. But what has happened is that the guy, for some reason, the administrator for the GitHub repository has set it as public, right? So meaning the entire code repo for a particular product is available for anyone to access all over the world. It means that GitHub repo is having access keys and everything, all those things. It was a bit of a nightmare, and it was how it is, right? And we have seen S3 buckets as well, in that we directly we're able to access it, and it becomes a bit of problematic out there, right? That is why it is important, right? You have to do periodic reviews. Why there's you have to do a pen testing once in a quarter or something like that is for the same reason. There is an dumb administrator out there who is configuring things. He may not be doing it on purpose. It's not that he's dumb on purpose, right? He may be clicking something instead of doing it. He might have done something. Maybe you would have tell, okay, let me remove this for some activity. I'll put it back in 5 minutes. It'll forget and it'll keep on going out there, right? No proper flow, no proper uh, request for authorization to do certain activities, and then monitor those things. Nothing is in place, right? So in those situations, accidental cloud disclosure do occur, and we have seen this happening when they're migrating. A lot of times we see people migrate from GitHub to GitLabs. When they are moving, they want it to be much more faster authentication. They disable it, or creating a new repo that comes in there. All those things play some very difficult role. Okay. Unauthenticated resource sharing. Cloud resource sharing can pose a significant security risk for cloud, and resource can include virtual machines, storage bucket, databases, all containing databases application vital to business operations. So this is same as having there is no authentication out there, and there's anyone can have access to that. No proper database, especially what we see in this situation is the problem of them. For ease of accessing during the initial time data, okay, they're having some issue with authentication mechanism, they'll disable it and forget it. This is very, very a major issue what we see. So unauthorized major concern. So how do you overcome this? Deploying in identity access management, right? You have to make sure there is multi-factor authentication enabled, right? A lot of people think is when you're talking about cloud and cloud identity access management, they only think about how do you give access to the ECT, what data is there and things under. Even your Gmail service, mail, cloud-based mail services, access control is also very important, because you are using a data is stored on your email as well. Its data is there on Google Drive as well, right? And we have seen that happen out there, right? You have to, we do reviews for a lot of other, because for as a compliance, we go each and every ID, what is the drives they are created, who's having access to what, and we'll see there are a lot of drives who's having a public access. Anyway, if someone has a link to that drive, they will be able to do that part. That becomes a very big issue. Always make sure there's a role-based access control, whether it's at the Linux level or the application level, and don't give, so that is very, very, very key out here as well. and making sure that is not done properly. What about endpoints, right? Use of cloud increases the requirement of effective endpoint security, as often endpoints connect directly to the cloud. New cloud projects provide a chance to re-examine security and respond to new threats, right? Your endpoints are predominantly your browsers or systems from where you're connecting, right? Especially in the future classes, probably not in the next cycle, we'll talk something about zero trust architecture, which is going to be the next component that's going to be there. In zero trust architecture, what it says is that by default, it is trusted. If the company has given the laptop, the application, we are going to think it is the laptop is trusted. That is going away. Even it may be a company provided laptop, the application should not trust, right? It is going to make sure it is going to constantly, before giving access to the application from to an endpoint, it is going to check the endpoint health as well, right? Is the antivirus in that endpoint, that system, up to date? Is the malware everything is up to date? Is the screensaver set? What is the password policy being allowed out there? Is a strong password policy and everything? All those things are going to be taken into consideration before giving that. The least amount of trust is going to be there, right? You need to have anti-malwares installed. You need to have some kind of an access control, making sure pen drives are not accessible and things like that. And browsers, what browsers they're using, what kind of a security updates happening out there, right? There are a lot of applications where it will tell you cannot use any other browser. You have to use a Google Chrome browser. You have to use only Mozilla for that, or you can use only Edge for that. All those things are coming up, right? And firewalls, built-in firewalls on the cloud level is also, endpoint level is also very important. Your antivirus software does a lot of these things, right? Nowadays, it takes care of the firewall, anti-malware, detection and access control. That is taken care by it. Enable and monitor log securely, right? This is one of those places, even in a medium-sized organization and large-size organization, they would not, they will connect logs, but it is not accurate, right? So we go to a lot of organization when they tell, okay, they got breached, and when we try to access their cloud, and we want to see, okay, what logs are there? There are some logs available out there, and it is not sufficient. And this I'm talking about not so medium organizations, maybe a larger organization for that, right? Not a big bank corporates, right? Whereas big corporates need, banks need log. There is a minimum log requirement for them by compliance. Otherwise, they will not be able to run the application. Small and medium, there's almost negligible or none at all in some cases, right? Who is monitoring what user activity is doing out there, right? One of the clients, one of the developers in the production server try to make some build changes because they did the build there. One point. Second point is that the build failed, and some reason the server went down. Right? The application is down, and they got to know 7 hours later that has happened because one of the client reached out and raised a service request telling that the application is not available out there. So now who did this? Right, and that is still a mystery right now. Okay, the main reason is all 10 developers have access to that server, and all of them are connecting to a single application, and we don't know who executed that part. There's no monitoring what have access to that part, right? And there's no logs also available for that. We know that particular command run at a particular time. Apart from that, that is because history command is there, but there's no log out there. There's no application level logs are also out there, right? And we told client, this is something you can't do anything right now. Probably you'll have to sit with your operations team, make sure each and every developer gets a different. All of them, do they require an admin? Even if they require admin, it has to be different users, right? give those user admin, so we'll know which user executed what command at what time. So that is important out there, right? And there's no security is like knowing you have to do this. There are a lot of things you have to look at perspective. Right? It is in one situation we saw because of the logs, there was not something security vulnerability is not there. But operation perspective wise, we took the log and gave a feedback to the management, and they thought did not understand, the particular way it was being done was not right, and they were not aware of it, right? So a excessive utilization of sudo commands, running services, running application, tools which are not required, cannot keeping the server as thin as possible. Right? That's also is right. So then again, looking at logs also helps you with identifying if people are given more access rights than they are supposed to use. Right. So we saw which are the users are having access and things. Why is it does not make sense, right? For them, the reason is some of them are working late night in their organization and they want to allow them to build that before next day comes in, but that is not the approach to go, right? Practices plays a very important role. Organization culture plays a very important role in security as well. Right? Misconfiguration is quite, uh, CS benchmarks which is going to be useful out here. Uh, Giving ports, opening ports which are not required, configuring firewall in a wrong way, allowing all traffic and not giving it, giving an encryption, standard, what encryption standard are you using out there, especially when you're giving SSH communication, right? So what if was there, right? Uh, how do you manage the external user, right? Are you going to give them that? What is the access restrictions? All those things are there. In a lot of times, nowadays it's a bit less. Nowadays is a bit less. What used to happen in traditional approach is that any tool that comes in, they come with a security as an alternative of them. Security was not main where they would have a default username and password. They will have other configuration set in a public way and things and all. And even today, if you see MySQL, it is, if you don't know how to configure properly, it will be in a bit of a secure place, unsecure place. So you have to be very good, Then again, we have also seen the development team when they're setting a database or setting an application, they give default username and passwords and things and all. Recently, they are not changed the default password for one of the services after logging in out there, right? So that was continued to be using out there. The default access permission example, MySQL is also there. By default, you can log in via sudo permission from the system. Linux permission is sudo only out there. That should not be allowed. A specific root user has to be created out there. And access rights, right? So which user is having access to what permission, what access? Because see, understand developers may need to push code into the or copy certain files into the server and things like that. But it does not mean that they can have access to the configuration files and things and all. So user management access level, it's going to be there. Sometimes they can push to a particular folder only. They can read from a particular folder only. All those things you have to take into consideration. And we need to have a checklist or a document describing what role, what access right is being given out there, right? At the same time, rather than creating a particular user every time user logs in, create a group or create a role, then assign user to that role or group, right? So it will be much more easier to manage access. So they don't have to worry about. In some cases, when they do it manually, assigning each and every user while removing, they may forget to remove one or two of them, right? That is where role-based access control plays a very important role for you, right? So how do we go about this, right? How do we go from this? So Solutions for this from a cloud perspective is making sure company-wide mandate training is there. This is not only from a security awareness training. Developers should have code security training. AWS engineers or cloud engineers should have their cloud specific training as that. If you're in Azure setup, you have to get an AWS, so the Azure security training and things. What are the common things that you need to know, right? They need to understand. They need to run a threat model of their, understand how things are there, right? Monitor key enterprise cloud application. This is very important, right? So one of the reasons the cloud, running things on cloud, is becoming more and more expensive is these are the certain things that we need to add to that part, right? The monitoring has to, they'll charge for that. Let's say if you want to deploy a web application firewall, it's going to be expensive again. A lot of other things are there, right? If you're running an on-prem, I can have an WAF setup in place in my, can use something like an WAF, mod security and things like that and work from there, right? That's important. Implement a zero trust model. Zero trust is you're not going to trust anyone, right? Previously, what used to happen, if you're a company employee, they trust you and they will give you access. As soon as they authenticate you, they're going to give you access. Now it is not like that. Everyone has to re-authenticate. Every request has to be authenticated and authorization check has to be done out there, right? Regular patch management, right? Organizations have to run this in a cycle, right? This isn't not that once you run whenever you want. We have to run that approach once in 15 days, or once in a month. That is very, very bare minimum. This is the least you can do, right? Because what happens when you're running a CI/CD pipeline is that you're running a patch management for that particular pipeline itself, right? What about the product where it is running? Your Docker container is running on some VM. Is the patches done for that VM, right? All those things have to be taken into consideration. Again, multi-factor authentication, as I told, everyone should be given, especially administrators should have a very strict password policy tied with multi-factor authentication. Right? So that's why you see even the phone numbers plays an important role, right? When you're working with Google, you're connecting from a remote some other machine, they'll ask you for a particular phone, what is the number, or are you sure? Please give permission from that, right? That's very important. Access management policy. Periodically identify and audit data buckets and their permissions, right? Audits play an important role. A lot of people will think is that audit meaning they're going to check your security controls. No, right? So what you're supposed to do is that you need to identify all the users who are coming under you. Let's say we're talking about, to make it simple. Uh, let's say there's an organization about 50 people. We need to have the information about all that 50 people. Constantly, we have check that anyone is offboarded and the system is updated for that. Their access rights has been removed from the mail. What are the application servers rights have been given to them or not? Is it been removed or not? That has to be taken into consideration in audits as well. That is very much important. We'll also audit who is having access to what and what permission is required, right? If there's a server, there's a root user who is having access root permissions to that. Who's having sudo permission for that? That has to be logged and verified, audited continually. That's important. Security is, I know, okay, why is that? It is important. Unfortunately, it is mandatory for all of it. Especially if you don't do it at an earlier stage, it will pile up. It will be very much difficult if the application becomes large. Okay, you have to start small and keep on increasing. Implement secure development lifecycle. Right, start identify threats as an earliest development lifecycle itself. Make sure software composition analysis is being run on the pipelines. Implement or manage lifecycle accounts and permissions. Timely updates, removal of unnecessary access. This we have seen in Azure. For me, I have not worked on AWS on this part. I think it will be there. Okay, so let's say there is a resource that has been created. Let's say I want to give So let's say there's someone called as a Steve. I want to give him access for a server for 20 days because he's a contractor who's going to work with us for 20 days. I've created an email ID for him and then access identity access management for that. And I will set that account permission for only 20 days. So what is going to happen is that I don't have to go after 20 days and remove the access for that. The cloud will remove that access permission for me itself. And that is the main advantage of here, right? So that cloud makes security a bit more easier because there's pre-tools already available out there, right? And finally, regularly run pen testing and vulnerability testing of them, which is important, right? There is no way of knowing what are the security principles that you have put up out there is working or not, unless until there's a pen test is done, right? So whatever the things, whatever we are doing out here is mainly because we can't do pen test quite often. It is a time and resource consuming activity. So maximum you can do is once in a quarter you can make it happen. In some cases once in a month, but I think that is a bit of a difficulty, right? So these are the things you will see if you look into that, probably we'll see at a much more detailed stage in next cycle, possibly. We'll check into that as well, right? So security as a service, right? We are getting in more into that. The clouds are providing technically, see, when I talk about web application firewall, whatever the WAF that has been provided by any organization, there's something called as OWASP mod security, right? They're taking that and writing a user interface and working on that part. But they can give other things as well, right? So they can provide data protection, data prevention, data loss, disaster recovery, how they can do it. Then now can talk about web security, database security. They always give a base set of services, and if you want something more, they're going to give that as right. Let's say if you're running an on-prem, right? If you want a log analytics for that, you want to maintain logs, probably you'll have to set up a lot of things manually, do it out there. Whereas in a software service, security as a service, probably you have to set up, click one option. Okay, I want this option. I know it's going to be charging me, but start logging the activities out there, right? So this will help you such identify those things out there, right? It can even monitor what's happening. Especially when you're talking about DDoS attack and things and all, when on-prem, it is very difficult to manage, right? In cloud, it knows where to block and things. It makes much more easier out there, right? So the main thing is it is going to cost effective. You will be given access to security experts because if you don't know how to, there's someone will be there to help you out with that. You will get the latest security tools and updates. It is constantly updating out there. You'll know how to set it up, right? I'll tell you one thing. A lot of people will, from a developers, they'll think, why is this taking so much time? A lot of things has to fall in place for an operations and team to work on, right? Even certain small variations, it's going to be very difficult. And when you're doing it manually, not as a service, right? If you're having easy to instance, you're setting things, you're installing security products manually, it can go wrong and things like that, right? So when you go for this, it is faster provision. You can just click on certain options. Setup is much more easier, right? And it's simpler to manage as well, right? It's a bit more easy to manage. So that brings us to the end of security, cloud security today. So any questions, guys? So any questions in cloud security, why certain things has to be done? What are the other examples on it? And any job descriptions or job related queries you're having, guys? You can also type the questions if you want, type it as well. Thanks, Jacob.